Investigation of failure in UNCD MEMS. UNCD stands for ultrananocrystalline diamond. It is a special form of diamond with a grain size of about 2 to 5 nanometers. It possesses properties very similar to that of a single crystal diamond, like the Young's modulus, the density, etc. UNCD. It has very low acoustic damping capabilities, which makes it a very good material for the usage in resonators. MEMS resonators. What are resonators? Resonators are vibrating devices which are used in radios, cell phones, etc. They are used basically for transmission of signals, to catch signals from one point to the other. These resonators, when fabricated using the ultrananocrystalline diamond as a substrate, face a failure problem which is not expected under an operating frequency of 150 MHz. Why? Because UNCD has very high Young's modulus and low density, which makes it an ideal material for usage in MEMS resonators, and that's the reason we don't expect failure when being used in the resonator. So this project deals with the investigation of failure of such devices. As we see in figure 1, the input or the IP port is where the signal is introduced into the MEMS resonator, which helps the piezoelectric material to vibrate in the lateral extensional mode and to create a lateral stress in the MEMS resonator. The OP or the output port collects the signal. So in this process, as we can see in figures 2 and 3, the failure occurs at the edge of the resonator. Sometimes it even happens that the MEMS device flies off. So such kind of failure is usually observed in these kind of resonators. So that means there is a stress concentration at the edge of the MEMS resonators, and that is which must be investigated. Further investigating this failure with the help of scanning electron microscopy technique, popularly known as the SEM technique, which allows you to look at devices even up to a nanoscale. We can see in the slide from figure 4 to 10, we can clearly observe the failure pattern from left to right respectively. Especially in figure 8, we see a cluster formation as marked with the red circle, which indicates a defect. When closely observed at this cluster, we see small voids which represent defects in the ultrananocrystalline diamond. As also seen in figure 9, there is a clear material mismatch is observed. Especially the lower part of it is UNCD and the upper part of it is a stack or the piezoelectric material, popularly, as I told, it's the aluminium nitride. So we can see a material mismatch clearly, and even in figure 10, as marked even here with the red circle, we can see voids which prove that the material is fabricated improperly. The table on the right side also reveals the composition of the material in the device. We can see the compositions of carbon, aluminium, nitrogen, etc. It is just to make an assessment of what is present in the material. Such evidences show that the failure is mostly mechanical in nature, and further investigation has to be done on the fracture energy density possessed by the ultrananocrystalline diamond as a substrate, and also the effect of fillet radius to reduce the fracture from happening at the edge of the MEMS resonators. I am Nitesh Yalavarthi, and I thank Dr. Raman Singh, my advisor, and my colleagues from the MEMS research group for their help.